All right, let's rock and roll. We are going to talk about where functions meet today. And what does that mean? That's kind of cool. So if we check it out, we'll go to the cool pen here. And so we are going to have a quadratic function. We know what those look like. We have a linear function. We know what those look like. So all our goal is, if we have those two, can we find the points of intersection? In other words, the bigger thing here is solve a system. There are many things that interact with each other, and if we have a mathematical model of one and a mathematical model of the other, this is the sort of questions that we want to ask, is when are they in equilibrium? When do they have the same value? Okay, so what are some of the possibilities? Well, it's pretty darn easy. We can definitely have 2 points of intersection. They can hit exactly once. So maybe you want to associate a few words here like tangent. Oh. And then you'd want to associate that with maybe something about the discriminant of a system. The discriminant of a system. And then finally, oh, too bad, so sad, right? All right. Okay, it is a pretty simple setup. We're going to set those equations equal to each other. So in English, we're just saying, hey, where do they have the same value? So when we solve that, we'll find the x coordinates that give us where they are the same y value. All right, so we get it to one side. I wrote b squared minus 4ac because that's going to tell us a lot about if they intersect, if they touch in one spot, or if they don't. So if they intersect in two spots, then you should expect greater than 0. If they touch, you should expect that to be less or equal to 0. And finally, okay, so once you find these solutions, then you are good to go. You'll find the points of intersection. So easy as that. Let's keep rolling. Let's do our first example. We have a quadratic and we have a line without technology. Of course, without technology. God, we don't want them to have all the fun. So we just set x squared minus x minus 18 equal to x minus 3. Do a little algebra. X squared minus 2x minus 15 equals 0. I think that factors nicely. X minus 5, x plus 3 equals 0. X equal to 5, and x equals negative 3. So that's the x coordinate. If we were to graph both of these, that's the x coordinate where they would intersect. So to find the points of intersection, points of intersection, POI, well, they both have the y value. So if I plug in 5 into either equation, that should be good. So if I plug into 5 right here, then I get to multiply out and I get to subtract. But if I plug 5 into here, it's pretty simple and easy and carefree and probably less chance of making an error. So your choice. I, of course, picked this one. 25 minus 5 is 20. 20 minus 18 is 2. If you're feeling a little lazier, 5 minus 3 is 2. Hey, the other one, negative 3. Let you figure that one out. Bam. All right. Oh, can we have two quadratics? Man alive. Can you kind of visualize how they could intersect? Could they intersect in 4 points? 3 points, 2 points? That's kind of fun. So just take some quadratics, mess around with them. I think you'll find that they also can intersect at 2, 1, or 0. Challenge yourself. See if you can make two parabolas intersect in 4 spots. No fair. I love it. No sideways parabolas. They're parabolas though. I give it to you. But we're just doing y equals. So part A says solve it. So I'm not going to rewrite it. I'm just going to get everything equal to 0. So this is A. So 0 equals, I'm subtracting that. So I get x squared negative 3x and minus 10. Well, gee, it's a math book. I wonder if it factors. Okay, I'm going to go with x minus 5 and x plus 2. No way. All right. If it didn't factor, it doesn't matter. Plug it in the quadratic formula. It works every time. So we get x equal to 5 and x equals negative 2. All right, so for solve, okay, so we got our x values. For what values of x is this greater than this? I don't know. What do you think? Now, this is fun. This is really fun because you have worked hard to kind of think about what parabolas look like. And just by the geometry of what they look like, you can answer this question. Notice this 2. Notice this 2. That means it's steeper than this one. They both go up in the air. They both open up. So a real horrible sketch is 5 and negative 2. Now, I don't care too much about being exact here. All I know is that they intersect at x equal to negative 2 and x equal 5. Not on the x-axis, maybe on the x-axis. I haven't found those 2 points yet. But in fact, I'm not going to. I know that they intersect. Let's say here and here. This one is steeper than this one. So if we draw this, which this isn't accurate if this is the x-axis, because, then this one has to be less steep but still go through those points. So wouldn't it be something like, I love it in math you can use the geometry to answer the question. So the answer for B is for what values of x is the green one. Why do I say it's green? Because it's not as steep as the 2x squared. For what values is that greater than? Well, it's greater than right here when it's above that graph. So my answer to this is when negative 2 is less than x is less than 5. So you're kind of going, I will now tell you that Desmos is a very valuable tool that you can graph both, get something that looks like that, and then you have to ask yourself the question, when is one graph above the other? Okay, moving on. Oh, tangent, finally. I love this problem. So this is asking us, can we make some choices in our life? We've got this k now. We can affect that line. We can change that line. And we want to make it so that this thing is tangent to this. So ideally what we have here is we have a parabola and we have a line, and we effectively get to change the k value, which means too much, bam. If we were to figure out the k value so that that touches in one spot, life is good. Back up. That means the system has one solution, or a repeated root, or is tangent. So this should bring up our b squared minus 4ac. Hopefully, let's start off by setting these equal. 2x plus k equals 2x squared minus 3x plus 4. What we're going to do now is kind of do what we always do. Let's just move forward and make everything equal to 0. 2x squared minus 5x plus 4 minus k. All right, that is a quadratic. That has solutions. But in this case, we've got this k that affects that. We want this to have one solution. So we choose to make b squared minus 4ac equal to 0. We are choosing that to make and force this system to have one real root or one solution, which gives us this picture. Ah, so cool! So let's plug in our b squared minus 4ac. So that's negative 5 squared minus 4 times a times c. A lot of people make the mistake. C is everything without an x, so that is that entire 4 minus k. And we will force this to be equal to 0. That's pretty powerful mathematics. I am challenging that and making that happen. So 25 minus 8, negative 8 times 4 is negative 32. Negative 8 times negative k is positive 8k. That just doesn't look right. Something. I want to pause. I'm back. I said it doesn't look right because I fell for my own problem that it didn't all come out perfect. And it is perfect. It's fine. We're going to get negative 7 plus 8k equals 0. And that gives us k is equal to 7/8. All right, that's all it asks. So when k is 7/8 right here, that line touches that parabola in one spot. It is tangent. Remarkable. All right, you're going to be asked to do some questions, find the points of intersection. You know, on the greater than or equal time, stuff like that, feel free to use Desmos to kind of see it geometrically. I think that's a really good use of that tool. All right, problem solving. I don't know how much you need about this except for just good old-fashioned experience and working with it. I kind of wrote some steps that I like to follow. When we do actual word problems, there's no X's given. It's like, here's the situation. Your job as a scientist or mathematician is to kind of like pull that, rewrite it mathematically, use mathematics, get an answer, and then translate it back into English. So that's the goal. So translation is key. We're going to do our math. Yay. We're going to find answers. Do they all make sense? Negative 12 miles is not really something you want to say out loud. So maybe if you said 12 miles in that direction, maybe you interpret that. And then we kind of challenge you to write it in a sentence. All right, let's look at something. A rectangle has a length 3 centimeters longer than its width. Its area is 42. Find its width. Well, right away we could just kind of start plugging and chugging and guess, but we want to use math. So I would start with a rectangle. We know its width is W or X or Y. Why do we always use X? I don't know. I'm going to do something different, like, just kidding, X. So that's our width. Our length is X plus 3, and we know the area is 42. Well, I hope you know that you find the area of a rectangle by multiplying length times width. Ladies and gentlemen, that gives us a quadratic. X squared plus 3x minus 42 equals 0. And that is something that you should be able to solve. It is possible to bend a 12 centimeter length of wire to form perpendicular sides of a right angled triangle with area 12 centimeters. I don't know. Is it? I don't know. Setting it up is really the key. So I'm just going to kind of walk you through that. And that may look like, maybe we say we have 12 total centimeters. What I didn't understand about this problem is the red part is not part of the wire. So it was X and 12 minus X. Area of a triangle is 1/2 base times height, or 0.5 times 12 minus X times X, and we know that it's 20. That I foresee is a quadratic and something you can solve. That's it. So I'd like to give you this. I think this will take you a little bit of time. I'm going to post most of the solutions so that you can go back and forth. My favorite is when you can manipulate that quadratic or that line when you're finding intersections. That's a really powerful kind of that next step of abstractness. So challenge yourself to think about what's happening. You will only get better. Thank you. From 20 to 15 minutes. I think we're moving in the right direction.